Hey there! So, if you've been following along, we've been making an application with Shader Doodle. And Shader Doodle is this fun way of working with WebGL. We're building a app with it to create GIFs. I guess we're doing memes or something because we have some editable text here that we can use. But we can choose our shader from this menu and even edit it ourselves with this lit code code editor. Both fragment and vertex shaders if we want to. Now we're pretty far along in this app. As you can see, we're almost able to select a shader from this menu and choose that shader and have it populate the new fragment shader and vertex shader. And more importantly, populate the actual shader right here, the display here. So let's continue on. We're actually going to run into a couple of different problems that are going to be a challenge to solve, so this is going to be interesting. Now, what I would expect, of course, is that we already have this reactive property for the current shader. So it should be easy to just populate that, right? So let's go down to our code editors and just, instead of hard coding this gradient shader, let's do this dot current shader. And likewise for the vertex shader code editor. And in the same Doodle TypeScript file, and remember, this is the only component in this project, so this is where all the code lives, pretty much. And do the same thing. Let's use this dot current shader dot fragment. And you might expect this to work, so let's try this out. So I'm going to use this menu here and select spiky purple alien blob. So as you can see, the fragment shader changes out, so this is what we'd expect. And yes, we do need scrolling over here because these shaders can get pretty long. But unfortunately, this area right here, the actual shader, isn't updating. So what gives? Did we make a mistake in our code? Let's crack open the dev tools and see what's actually happening. And as we open the Shader Doodle Shadow DOM, we can actually see the updated fragment shader. So this matches what we see here. So why don't we see the update? Well, you know, when we talked to Merle, he gave us the answer, and that is, it's an upcoming feature. It's just not done yet, so you can't just swap in and out different shaders on the fly like this. It's a future feature, so we need to do something clever ourselves here. So I have an idea, and my idea is basically to kind of work around or hack around how lit updates things. And to explain, we have this current shader variable right here, right? So lit watches this because it's a reactive property, and when current shader changes, it's going to update just this tiny bit of the DOM. Whatever is inside this variable right here, whatever is inside this object, it's going to change, but nothing around it changes. So Shader Doodle does not get torn down. Shader, like everything stays the same except for this tiny bit right here. So my idea is this. Let's take this entire Shader Doodle component, tear it all down, remove it from the DOM completely, and then when the shader changes, reinstantiate it, add it back to the DOM. We're completely taking this out of Lit's hands and managing this aspect, this small aspect of the DOM ourselves, but we're still letting Lit take care of everything else. So this is what we're going to try. So to start, I'm going to remove Shader Doodle from this component completely. So we'll have this empty div, the Shader Doodle container. And then we're going to jump into this shaders.ts file that we created, which is, again, it's just a list of all our shaders, but we're going to add some kind of factory creation method here. We're going to add this function called createShaderHTML. And what's going to happen is we're just constructing a tag, not through HTML tag templates, not through anything except for just normal strings. And so we're constructing the Shader Doodle tag just with string concatenation here. And we're going to have some extra logic that, you know, if the shader has a texture and it's a webcam, we're going to add the webcam texture to Shader Doodle. And likewise, if it's just a normal, you know, image asset, we're going to add that texture as well. But otherwise, like I said, we're programmatically adding the shader fragment and vertex. So now that we have this factory function to create our tag, let's jump back to doodle.ts. Now in doodle.ts, I'm going to add a shader update function. And now what the shader update function does is it's going to do a few things. It's going to take our code editors, our lit code editors, and set the inner code, the text of the code, programmatically based on the fragment and vertex shaders. This is already done, but we're going to do it a different way, just programmatically through the lit code API. Also, what we're going to do is we're going to take the Shader Doodle container element, the one we just cleared out, and we're going to set the inner HTML to absolutely nothing. So this is going to completely destroy Shader Doodle in the DOM and leave a hole where it should be. So it has to, like I said, it has to tear itself all the way down, and it'd be left with nothing. So, and then what we're going to do is we're going to take the same container, set the inner HTML to our new create shader HTML tag that we constructed via a string. And just this act of tearing it down and then building it back up means things have to reinstantiate again. And so we're working around this future when Shader Doodle has the ability to just swap in things piecemeal like this. We won't need this. But for now, it is an alpha after all, so be easy on Merle. But for now, we'll run with this hack. So this should work. So we need to, first of all, import create shader. So let's do that. And of course, we don't need this gradient reference anymore. Now, my IDE is highlighting a couple things that are wrong. One of them being, well, actually all of them being that it can't find these elements that we have variables around. I haven't set these up yet, but normally you might expect we have to do this dot shadow root dot get element by ID. And then the ID of the Shader Doodle container is Shader Doodle container. So let's copy that over. And we would use this to set the inner HTML. It's a long way of doing this though, and guess what? We can do something much easier with Lit's decorators. So what we're going to do is we're going to use the Query Decorator. So let's just add all of these DOM elements in at once. So here is the Query Decorator, and oops, we do have to import this one. So let's import this query just from the decorators file. And with that, we're just saying, use the decorator query and look up fragment. And of course, you should all know that the hashtag denotes the ID of the element. So this is basically a query selector, but in decorator form. So it's a lot nicer to work with. And then we're just assigning it to this fragment code editor element, or the Vertex one, or the Shader Doodle container one. So, and we're adding another one to actually pick up Shader Doodle, and we're query selecting just the Shader Doodle tag right here, the custom element name. So we have all these built in, and our code is not complaining anymore. So let's do one more thing though. When this component loads, we're going to call first updated. Now, first updated is a lit element lifecycle method. So the very first time our component updates, it's going to call this. And property values, yes, we're using TypeScript, so we do have to import this. I'm going to make my IDE do this because I can't remember where to import it. And let's just check. Property values. Oh, it's just part of lit. Okay, cool. First updated, yes, like I said, it's going to happen when the component is first updated, and it's never going to get called again. We're going to call shader update, our new function to update our shader here. So we're going to call first updated to, when this component first loads, we just want to, do this switcheroo that we're doing. Set the inner HTML to nothing and then set it to the shader tag we just added. So let's try that and make sure our shader still works. And it looks like it does. There doesn't seem to be any change here. We do need to tell it to update when we are using these menus though. So let's do that. So here's the picker, the drop-down menu. And after setting the current shader, we're going to do the shader update. And same thing for after we set the texture as well. Now, hopefully we'll finally see our menus working and see some different shaders than this lovely multicolor animated shader. And I come back to spiky purple alien blob. Let's try that one. And there it is. It does look like a spiky purple alien blob, I think. Let's try one more. Starry flare. All right, that's pretty cool. And again, because Shader Doodle does not yet support the act of swapping things in on the fly, we are tearing down this entire element and then adding it back to the DOM just by using inner HTML. Inner HTML, before lit was a thing. I've been working with web components for a while, and I kind of outlined this method in my book about just using inner HTML to set everything. It's not performant, so thankfully we have Lit now, and other templating libraries like Lit that let us do this declarative programming style. But at the same time, it's kind of nice that we can mix and match these things, even in something that's completely controlled by Lit. So I really appreciate that we have this escape hatch. Now, again, we still haven't talked about the shader toy style switch here. Um, let's go into our shaders. Each of these shaders may or may not be shader toy style. So let's find one. This lava one, it's kind of a lava lamp. It does come from the website Shader Toy. I copied and pasted. We'll do that again in the future. But the Shader Toy website, it actually has some different uniforms, so different variables that go into these shaders. Not all Shader Toy shaders will work here, but I've been having some pretty good success copying them over. But for them to work, you need the same uniform styles. So that's why when I do copy things over from Shader Toy, I have this is Shader Toy boolean set to true. But back in Doodle TS, we have to make our switch here act accordingly. So let's add this change event. So like we did with the code, we're deep cloning current shader, so we're not referencing the original shader object in our list. Then we're just setting is Shader Toy to the current value of if it's checked or not. And then we just do a shader update. And whether or not it is a Shader Toy shader, this is reflected in this Boolean attribute, whether it's checked or not. So if it is Shader Toy, if this evaluates to true, checked will be present as an attribute. Otherwise, it won't be. And again, this is what that little question mark means. It'll be there or not there depending on whether it evaluates a true or false. And one of the last major bits of functionality is actually being able to type and edit this shader as we go. So let's add an update event listener on lit code. We'll start with the fragment shader. So what we're saying is when lit code gets updated, meaning when the user types into lit code and changes what's there, we're grabbing the code, and if the code doesn't exactly equal the current fragment shader, we're doing another deep clone and assigning a new name of custom to what's now the current shader, and then we're setting the ID equals -1, so we'll never be able to find this in our picker list, in our dropdowns. And then we're assigning the code to the fragment. And of course, we don't want to quite update on the fly the shader yet. We don't want to tear down Shader Doodle and build it back up again, because if the user typed one character, well, the shader is probably broken at that point because the user will need to type more characters to actually make this work. So we're going to have a reload button that we're going to use. But first, let's do the same thing for the Vertex shader. And it's exactly the same code. It's just Vertex instead of Fragment. So here we go. And like I said, we have this reload my shader button. So this is after the user has been editing the code and they think, okay, this shader, it should work. It's good enough. So let me press reload and reload this stuff. And all we're going to do here is add a click handler that says shader update against the current shader. Now I think this is going to be enough to get all of this working. So let's try it out. Let's load, again, spiky purple alien blob. That's a good one. And note, while we load this Shader Toy style switch is set to true because this is coming from Shader Toy. It's in our object as true. So it automatically updated this check mark when we loaded it. Let's try to find one small thing that's going to have a big impact on how this thing looks and renders. So I'm going to look at this. I think the spike size thing makes sense. So let's make the spikes a lot bigger. Let's make them, instead of 0.25, let's make them 0.125. So I'm going to click reload my shader. Those are definitely bigger spikes. Can we do anything else? Can we do violet color? Let's check that out. Let's reduce some aspect of the violet color. I guess this is RGB. So let's reduce the blue, and I think that should back off the purple a lot. So let's make this 0.1, and I think this is going to back off the purpleness. Yes, it is mostly yellow and orange, I guess, now. So we are actually editing this shader live as we go. And of course, this placeholder text, it says custom now because we've edited here, and our ID for our shader now is actually -1. So when we look at our big list of shaders in shaders.ts, there is no -1. And so this list can't find the shader we're using because of that ID. And so it falls back to this custom placeholder. Let's load up one more shader because this is kind of fun. Fractal Pyramid. This is kind of looking cool. Can we randomly change this maybe? So let's do, I think we can make this faster by doing itime times 0.8 instead of 0.2. So let's reload that and see if it is faster. I think that looks a lot faster, right? Cool. I'm excited. We have a lot of this working. The only thing we really have left is recording and saving our GIF, and that's coming up next. So stay with me. We're almost done with this thing. We got something cool working here.